So hello everyone. Previously we discussed about the merge sort and also the divide and conquer approach. So we are discussing about the sorting algorithms, right? So next let's discuss about the bubble sort algorithms. So bubble sort is a simple algorithm. Mainly it is comparison based sorting technique. So let's discuss the idea behind it. So the idea behind it is to repeatedly step up through the list. So we are repeatedly stepping through the list and we are comparing the adjacent elements and swap them. First, we will compare the current element with the adjacent element and we will swap them if they are in wrong order. So you have to just keep in mind this line. The main idea is here what we will be doing. So we will compare the current element with the adjacent element and then we will swap them if they are in the wrong order. So this is what we'll be doing in the bubble sort. So by doing this, so the largest unsorted element bubbles up and bubbles up to its current position in each iteration. So this is the idea mainly, right? This process is repeated until the list is completely sorted or fully sorted. So mainly let's discuss pass 1 along with up to pass 3. So first one here, let's discuss, suppose this one I'll just consider pass 1. So here what happens, the largest unsorted element is moves to the last position. So the largest unsorted element moves to the last position. So if we are having 1, 2, 3 in the array, so here 3 will move to the last position. This will be unsorted element and it is moved to the last position. Second pass, what will be the second pass? Here I'll just come here. Let me come here mainly. What will be the second pass? The second largest unsorted element is moved to its current position. Nothing but here. It comes to here. Before this one here. So here now it will be 2, 3. Pass 3. What happens? Here we'll continue this process until the array is sorted. So finally we'll get this one as 1, 2, 3, 1, 2, 3, right? So this one what we'll be doing here. So let's try writing the code and let's try to understand the code, and also let's discuss about the time complexity and the space complexity at the end. Let me delete this one. So I'll just come here. First step is here, just give me a second. Yeah, I'll just come here and give bubble sort, right? Let me consider array as the parameter. Here's what is our first step. We have to get the length of the array. So I'll just write here length of the array. So after getting the length of the array, we'll be making use of the let's go with the iteration. So nothing but the outer loop, will be making use of the outer loop to control the number of passes. So here it will be, let's start from 0. This will be till last. So I plus n minus 1. Also let's increment I. This is one thing. The next step is, so we'll be making use of the inner loop to compare the adjacent elements in the unsorted part of the array. So we are comparing here the current element with the adjacent element, right? So the inner loop is, what does the inner loop do here? It compares the adjacent elements in the unsorted part of the array. Nothing but we can write in this way. So it has to be, let j equals 0, j less than, it will be n minus I this time, and finally j less plus. So after doing this one, we have to compare the current element with the next one. So for that I'll just make use of the if condition. Currently if it is array of j, if it is greater than array of j plus 1, then what we will do in the step 5, we will swap if the elements are in the wrong order. So we have to swap if the elements are in the wrong order. So let's swap if the elements are in the wrong order. So this has to be within the array, right? So I'll just consider array of, so sorry, just give me a second here. This has to be within the array. So I'll just consider array of j and let's consider array of j plus 1, the next element. If it is, this has to be equal to array of j plus 1 and finally array of j. So I hope this is clear. So what we'll do here, after each iteration of the inner loop, the largest element of the unsorted part moves to the correct position. So the outer loop continues until all the elements are sorted. So this is how the bubble sort basically works. So let's see with the example. I'll just consider here. Let me give const array equals, I'll just take some random element 65, 42, 64, 31, 45, 77, 98, 62, and finally 6. So I'm just considering a random array. Let me give console log of here. As usual, I'll be taking original array and let's give I have considered array right here. This one array. Also, we have to get the sorted array as well. So let's make use of the bubble sort of, let's call the function bubble sort here. Bubble sort of array, right? Oh, this one. Sorry, yeah. Finally, let's log it. I'll just make use of console log of this one. We have to get the sorted array. So I'll just give here sorted array and need to get the array. So this is fine. So let me explain this, what we have written in this code and very shortly, right? So the bubble sort function here, this one, the bubble sort function, it sorts the input array using the bubble sort algorithm as we are going with the bubble sort algorithm. So it iterates over the array multiple times, comparing the adjacent elements, and we are swapping them if they are in the wrong order here, as I have said. So also each pass pushes the largest unsorted element to its correct position, like bubbling to the top. Third step, finally, this process is continued until the array is completely sorted. So mainly I have explained the same thing while writing the code, right? So finally, let's discuss the time complexity and the space complexity. So due to the nested loops here, just give me a second here. Due to the nested loops we have made use of here, you can clearly see, right? We are making use of the nested loops here. Due to the nested loops we have made use of, the total time complexity would be big of n to the power of 2, nothing but big of n square. And also the space complexity would be big O of 1. Why? Sorting is done in place with no extra memory is being used here. So that is the reason the overall time complexity would be, it will be big O of n to the power of 2. Also, the overall space complexity would be big O of 1. So I hope this is clear. So this has to be, let me mention here, space complexity, right? So the time complexity would be big O of n square or big O of n to the power of 2. And here the space complexity would be big O of 1. So this is it. Thanks for watching, guys. So here I forgot one thing. I didn't run the code, right? So let me run the code for the bubble sort basically. So we are getting the same, this one, same array, right? So this is not being sorted here because this has to be n minus I minus 1. So let me run the code again here. So I have made mistake somewhere. Let's check the code correctly. Also I have forgotten here this array, right? This one array that we are considering. Here, this one has to get closed here. Also, we have to open the braces here. So this mistake I did. This is fine. Let me run this one again. So yeah, now you can clearly see the array is sorted in the ascending order. So you can also check for the descending order. So I have showed you this array is sorted in the ascending order. So 6, 7, 31, 42, 45, 62, 44. This one 77, 98. So here I missed one thing here. N minus I minus 1 it has to be, right? In this particular, this one. In this loop. So the inner loop here I made a mistake. Also here. So this array has to close here and I have to open this one array. So that is why we were getting the wrong output. So now this works absolutely correct. So this is it. Thanks for watching, guys.